Hi everyone, thanks for checking out this video. So this is going to be a lesson on the selection sort algorithm. So I'm going to show you guys the basics of the algorithm and how it's implemented, and then how to write it in Python. So this is the second video I'm making on a type of sorting algorithm. I previously made one on bubble sort. So just to quickly repeat something I said in my previous video, the reason sorting algorithms are interesting to study in computer science is because sorting a list of numbers is an example of a problem where you can write more than one algorithm to get the job done. There's actually a bunch of different algorithms you can use to get this job done of sorting a list of numbers. And it seems like a very easy problem, and that's part of why it's used as this problem in like algorithm design, is because there's many ways of doing it. And with different algorithms that all get the job done, you can think about like which ones are more efficient and which ones are less efficient, and like which ones are like scale better to larger arrays, and which ones don't scale as well. So that's kind of why it's used as like a basic problem in algorithm design. It's useful as like an example problem to figure out how to like evaluate which algorithms are better and which ones are worse when you have a bunch of algorithms that all get the job done. Okay, so with that being said, I'll just get into it. So we have this array here of numbers, and we want to get it sorted from least to greatest in terms of the value of the numbers. So the way we're going to do this with the selection sort algorithm is we're basically going to iterate through the array a bunch of times. And with each like passage through the array, we're going to look for the minimum number that we haven't seen so far, and we're going to select this minimum number and then put it in order at the beginning of the array. So I'll just show you guys how it's done for this example, and then we'll get into the Python code after that. Okay, so on our first pass through the array, we're going to start in the index 0 position. So we're just going to start here, and then we're just going to iterate through each value and then keep track of the smallest one we've seen so far. Okay, so the first value is 4, so I'm just going to circle 4 just to show that it's the smallest value we've seen so far. And then with each one, we're going to check and see if it's smaller than our current smallest seen value. So the next value is 1. So this is smaller than 4. So I'm now going to circle 1 because this is now the smallest value we've seen so far. The next value is 7. 7 is not smaller than 1, so I'm just going to keep going from here. And then the next value is 3, and 3 is not smaller than 1. So just keep going, and that's the end of the array. So on this first pass through the array, the smallest value we've seen so far is 1. So what we're going to do now is we're going to swap places and put 1 at the starting index we started at, and then put the value that was previously at the starting index in the place where 1 was. So I'm basically just going to swap these two values here. Another way of doing this, by the way, is you could just make a new empty array and start filling it up with all your minimum values. That's another way of doing the same kind of algorithm, but for here, I'm going to show you guys the way of doing it that doesn't require any additional data structure. It's called an in-place sort, because you don't have to define any new array. But yeah, for now, just going to swap the 1 and the 4. So now our array is going to look like this. And for our next pass through the array, we're going to move our starting point down like over 1. So we're now going to start from here, okay? So this, whatever's to the left of the current starting point, that's the part that's already been sorted. And whatever's to the right of the current starting point, that's the part we still have to sort. So now we're starting here. And we're basically going to do the same thing, but starting from this starting point. So I'm going to circle 4 because that's the smallest one we've seen so far. And then we iterate through each value. So the next value is 7. 7 is not smaller than 4, so we're just going to keep going. Still, so far, 4 is the smallest one we've seen. And then the next value is 3. So 3 is smaller than 4, so I'm going to circle 3 because this is the smallest value we've seen so far. And then, okay, and that was the last value. So now we know that on this pass through the array, 3 was the smallest we saw out of all the unsorted numbers. So now we do the same thing. We swap places here. So now our array is going to look like this. And then, just like before, we move the starting index over 1. So now we're going to be starting from here. And remember, like I said, everything to the left of the starting index has already been sorted, and everything to the right still needs to be sorted. Okay, so now we just do the same thing again, starting with this starting index. So we're going to start with 7, circle it because that's the smallest one we've seen so far. And then we go to the next value. 4 is smaller than 7. So we're going to circle 4 because now this is the smallest one we've seen so far. And then this is the end of the array. So now we do what we've been doing. We just swap these. And now our array looks like and okay, so now it has been sorted. And so how do we know when we can actually stop? Because we can see visually here that it's sorted, but how do we actually know when it's okay to stop and have it be guaranteed to be sorted? Well, we stop when we get to the second to last index. That's the last index we need to check for. Because if we were to keep going and move the index over 1 more, well, that would be the last number we have left. So if we've sorted everything except for the last number, then we already know that the last number must be the maximum because everything to the left of it has been already sorted. So our stopping condition here is when we finish doing the pass through from the second to last index. We don't have to actually do the last index. But yeah, so this is how the selection sort works. So next I'll show you guys the Python code for it. Okay guys, so the first thing we're going to do here is just define the same test array we were using on the whiteboard. So I'm just going to make this test array, let's see, 4, 1, 3, 7. And just a quick note too, I'm kind of using the words list and array interchangeably in these sorting algorithm videos, just because in Python, these data structures are called lists. But if we're talking more in terms of like general computer science, they're really like the Python list is like a type of dynamic array, and a lot of the times when you see these like sorting questions, they talk about arrays. So even though they're called lists in Python, I'm kind of using like the general computer science terminology in these sorting algorithm videos. But yeah, just a quick note about that. I'm using like list and array interchangeably here. But okay, so we're just going to start using this for our test array to work on, and then we're going to define the function selection sort. And it's going to take an array as an input, and basically we need to write a for loop, really like 2 nested for loops to do what we were doing on the board. So we want to like keep passing through the array. And each time we're going to move the starting index over 1, and then with each pass through the array, we're going to keep track of the smallest value we've seen, and then at the end, after the pass, we're going to swap that smallest value with the value at the starting index. Okay, so the way we're going to do this is with, like I said, like 2 nested for loops. So the first for loop is going to be keeping track of where the starting index is. So we're going to say for starting index in range len array in -1. The reason it's -1 here is because, like I said on the board, we only need to go up to the second to last starting index, because if we get to the last index, we already know that that's like the last value that's left, so that must be the maximum. So we only need to go up to the second to last index when we're doing this. Okay, so with each like pass through the array, we're going to keep track of what our minimum value is, and really to be specific, we're going to be keeping track of actually the index of the minimum value. So I'm just going to call this this variable here min index, and we're just going to start it off with the starting index. Okay, so what we need to do next is just like we did on the board, we need to pass through the array starting at our starting index and then keep track of which value is the smallest one we've seen so far. So to do this, we're going to use a nested for loop. So we're going to say for I in range starting index to the length of the array. So for each of these index values, we're going to say if the array at this index I is less than the minimum value we've seen so far. So this is basically what this if statement is checking. We're saying if this value we're looking at is less than the value of the array at the index of the smallest value we've seen so far. If this is true, we're going to reset the minimum index variable to be this index value I. So that's how we're keeping track of the index of the smallest value we've seen so far. And so we're going to do that as we pass through the array. And then after we're done with this passage, we're going to, like we did on the board, swap the smallest value that we found with the value at the starting index. So to do this swap, we're going to use this, this temporary variable temp. We're going to save temp to be the value of the array at the starting index. And then we're going to say the value of the array at the starting index is going to equal the value of the array at the minimum index, which is, remember, just the minimum value that we saw on this passage. And then we're going to say the value of the array at the minimum index is going to be equal to the value that was our value at the starting index. But remember, we saved that in temp to be able to do the swap here. So we're just having this equal temp. So basically, this block of code is just swapping the value at the starting index with the value at the minimum value index that we found, just like we did on the board. Okay, so at this point, after this completes all of the passages through, we should be left with a sorted array. So then the thing left to do is just to return it. And actually, the way we've written this function, we actually don't even need to return anything, because if we call this function on an array, even without returning anything, it will still sort the array. And if we just reference the array again, it will now be sorted. But I kind of like to return something just because personally, I just prefer working with it that way. I like the function to return the sorted array just so I can get an array out of it. I just personally find that to be easier to work with. Okay, so let's just test this out on our test array and see if it works. So the first thing we're going to do is just print test array in its unsorted form. And then we're going to say test array equals selection sort test array. Again, we don't even need to return it into a we don't even need to return it like this. We could just write it like this, and it would still sort the array just because of how we've written the function. But I like to do it this way just because it's just my preference. And then after sorting, we'll print it again, and then hopefully now it should be sorted. So let's see. And yes, it looks like it worked okay. We see it's now in the sorted form after calling the function. But okay, so that was just our small test array we're using. Let's actually try actually generating a large random array and then see if we can sort that. So I'm going to import random at the top. And I'm going to generate a random array to test on. Or actually, you know what? I'll actually just copy and paste out of my my last video. I'll just copy and paste this block of code out of the previous video I did on bubble sort. But yeah, this is just getting a list of random numbers in this range 0 to 10,000 and saying we want 100 numbers. And then I'm basically just, this block here is just printing this list of random numbers unsorted and then calling our, make it our new function name here, calling our selection sort function and then printing out the hopefully sorted list. Okay, so let's give this a try. And yeah, so it looks like it worked. This is our unsorted random list at the top, and then this is it after sorting. Yeah, so we can kind of like sort of visually see that it's in order. But if you guys don't believe me, then a test for yourself can be to write a function to check if it's actually sorted. In fact, you know what? Let's just I don't know why I'm being lazy. Let's just do this right now. I won't leave it up to you guys. I'll just show you how to do it. So let's just write a function to check if a list is actually sorted. So I'll say just call the function check if sorted. It's going to take an array in. So it's going to be kind of easy to do this. We're just going to say for one thing, it's going to return it'll just return false if it's not sorted and return true if it is sorted. So we're basically just going to say for I in range len -1, we're going to the second to last index. We're going to be checking pairs. So we need to just go to the second to last index because that'll be the last pair we need to check. And then, so for all the index values in this range, we're just going to check if the value of the array at index I is is greater than the value of the array at index I plus 1. If this is true, then that means it's not sorted properly because it's supposed to be sorted in order from least to greatest. So if this ever is true and the value at index I is greater than the value at index I plus 1, if that's ever true, that means it's not sorted properly. So we're going to return false if this ever is true. But then if it passes through this whole for loop without ever returning false, if it makes it through this whole thing without this ever returning false, then we know that it is actually sorted properly. So then we're going to return we're going to return true. Okay, so I'll just so we can use this, I'll just put it up here, and then instead of just printing out the actual lists, I'm gonna evaluate our function on them. So I'm just gonna call check if sorted on this random list. And then we're gonna do the sorting, and then I'm gonna check if sorted again. And then maybe just okay, so if this works properly, it should evaluate to false here and then true here. So let's see. Yes, so it looks like it worked. So when we just have our random list of numbers, we check if it's sorted, it says false, and then we call our sorting function, and then we check if it's sorted again, and it says true. So yeah, this is just like a simple function to just check if your list is sorted properly. Okay, guys, so that's all I have for you today. So like usual, the code will be up on GitHub if you want to download it. If you have any questions, just let me know in the comments, and I'll try to answer them. But yeah, thanks for watching, and probably going to keep making like maybe 1 or 2 more of these sorting videos, and then we'll do some videos on how to compare between different algorithms and see which ones are like more efficient and which ones are less efficient. But okay, so thanks for watching, guys, and see you next time.